Hi, my name is Lora Kasselman, and I'm at the CUNY School of Public Health. And I'll be talking to you today about my project, which was just in New York, on the associations between diet, obesity, the gut microbiome, and colorectal cancer. So a little bit of background. So colorectal cancer is the third most commonly diagnosed cancer in the US. It's also the fourth leading cause of cancer deaths in the world. The incidence is strikingly variable in the US and globally. And what it really is, it's really a disease of development. So as countries move up on the development index, the incidence starts to increase in colorectal cancer. There's a very strong impact of lifestyle factor, which tracks with the disease of development. So things like diet and smoking. So what is the link between lifestyle factors like diet and the development of colorectal cancer? So we really need to try to understand this relationship between lifestyle factors and colorectal cancer. And that's what my project was looking into. So I also want to give a little background about the microbiome. The microbiome is a really hot topic right now. So have you guys heard of kombucha or kefir and things like that? So it's a really hot topic. So the microbiome is a community of microorganisms, and as disgusting as it sounds, they are all over us and inside of us right now, and there's more of us than them. But they're mostly bacteria, sometimes they're yeast, but they're really important in maintaining a homeostasis and health. So a lot of hot research is coming out saying that if you alter the microbiome in different places in your body, you have a lot of problems. So it's associated with diseases such as obesity, diabetes, even mental health issues. So there's a real opportunity for us to see are there alterations in microbiome potential causal mechanism between lifestyle factors and colorectal cancer? So my objectives were to extract microbial signatures from microbiome studies of diet, as an example of a lifestyle factor, and analyze them for overlap with changes in the microbiome in colorectal cancer. And so some of my objectives were to use R to import and analyze data sets and to visualize data. So just because I didn't leave this country doesn't mean I didn't encounter problems. So I'll talk about that. So really, most of this was, I focused on the first objective due to some problems. So when I proposed this project, I thought it was, oh, it's so easy, it's a literature search. And actually, it was very challenging because I had to sleuth through a lot of articles to find articles that actually gave me the data that I could extract out of them that was correct. So there were a lot of articles that seemed like they would be really great for my project, and then it turns out after spending a lot of time looking at them, I had to completely scrap it. So after going through a lot, I came up with 4 colon cancer articles and 8 diet articles that were actually appropriate for me to extract data from. So here are 2 examples. So the enterotype-based analysis of gut microbiota along the conventional adenoma, carcinoma, colorectal cancer pathway. It's very wordy. And then an example for the diet one, so microbial enterotypes inferred by the Prevotella to Bacteroides ratio, and during a randomized control diet intervention. And I just wanted to show you those titles because I'm going to talk about those studies a little bit further. So here's an example of a colorectal cancer paper that I extracted data from. So in this paper, what they did was they looked at patients that were coming in for colonoscopy screenings, and they gave them their colonoscopy screening, and they decided, okay, what do they have inside them? Do they have polyps? Do they have nothing? Do they have adenomas, which are non-cancerous, or do they actually have colorectal cancer? And at the same time, they took stool samples. And so this is really important for my research. They need to have stool samples associated with their diagnosis. And do you know how the pointer works? Is it the up? Oh, the middle button. Oh, okay, thank you. Right, and so you can see here, so this is just one image from this paper, and I blew up some images. So what each box here, this represents a different bacteria that they sequenced out of the stool sample. And they stratified by the diagnosis, so whether the patient was normal at screening, had an adenoma, or had a colorectal cancer. And so for example here, you can see this is for Eubacterium. So one particular bacteria that they found in the stool. You can see here that in patients with colorectal cancer at the same time as their screening, they had significantly lower abundance of this particular bacteria. And here's just another example from the same paper, a different type of bacteria. You can see here colorectal cancer patients had significantly higher abundance of this bacteria when they analyzed their stool. So this was most of my job, was going in and looking at all this data and extracting out where there was significant downregulation or upregulation of different types of bacteria. And so this is another example of a paper with a diet example. So in this paper, they looked at, this was done over in Europe, and they looked at the average Danish diet, which is very Western. It's like the Western diet. So very low in fiber, very low in fruits and vegetables. And there's something called the New Nordic Diet, which was a new recommendation. I guess it's like the My Plate kind of recommendation, or the what we do here. And they suggested that people need to start eating more fruits and more vegetables and more grains. So what they did was they did a controlled trial where they took these people and they measured their stool before they put them on this New Nordic Diet, which contained more fruits and vegetables. And they took their stool, and then they put them on the diet, and then they took their stool again to see how the microbes changed in their gut. And here's just one example. You can see here the average Danish diet, so this is like the quote-unquote bad diet, is in white, and the New Nordic Diet is in black. So the New Nordic Diet is the one with the more fruits and the more vegetables. And you can see here, just an example, so this is actually E. coli here. So if the ADD, so that's the average Danish diet, that's the bad diet, they had more E. coli present in their stool after they were on the average, their normal diet. But the people who were put on this better diet with more fruits and vegetables, they had lower abundance of E. coli. And alternatively, there's another bacteria, Methanobrevibacter. Those people who are on this New Nordic Diet, there was an increase in this abundance of this bacteria in their stool. So you could see clearly that in colorectal cancer patients, there are differences in the bacteria, and also in patients on healthy diets versus unhealthy diets, there are differences in the bacteria. So basically my question was, is there an overlap between the two? Okay, so after I went in and extracted all these different bacteria from what bacteria were up in colorectal cancer patients and what bacteria were down in colorectal cancer patients. And you can see here I underlined some of these because I thought they might look familiar to people. Do these names look familiar to anybody? Yeah, you've seen them before, right? Can anyone say where they might have seen some of these bacteria before? Probiotics, yes, thank you. It's like I planted you in the audience. Okay. So this is what was up in CRC, and I'm going to get back to that in a second. This is up in CRC and the different ones that are down in CRC. And you can see here that these are ones that are up in CRC and ones that are down in CRC. And so then I was supposed to use R to do an analysis, and there were a lot of technical challenges, and I didn't. So I ended up using Excel to try to find the overlap between the two. So what was interesting here is that there were significant changes in the gut microbiome that were similar between CRC and diet. And it was not just in one paper. There were multiple papers where these bacteria were up in CRC, where they were also up in diet. And this might suggest that diet-driven changes in the gut bacteria could lead to the development of colorectal cancer. And there have been a lot of studies in mice that have shown this to be the case, but this is all in humans. And so you could see that these were ones that were up, so there was an increased abundance of these in both diet and CRC. And if you look in here, these are ones that were decreased in diet and CRC. And so I want to go back to the probiotics. So some of you, so someone mentioned probiotics. And so do you know where this is found every day that we can find it? Yogurt, right? This is usually in yogurt, right? But it's found to be low in the stool samples of people who eat a quote-unquote bad diet and who have CRC. So what does that mean, right? So I found some common changes in the gut bacteria between CRC, and it may provide a link or a mediated link between lifestyle changes and the development of CRC. And so some of these overlapping bacteria are already well known. So this provides an opportunity that we can do some interventional studies. What I wanted to talk about were some of the limitations, so that this was very time intensive, but it can be accomplished from anywhere. So I appreciate the opportunity to be part of this study because I work full time and I'm a mom. And so I needed to be able to not go overseas, right? I had to stay home. And so without the ability to do this project at my home, I would not have been able to participate. So thank you so much for the opportunity. But because I was at home, I had limited access to mentors because I was not on site. However, my mentors were available by WebEx or Skype, so I was able to talk to them that way. One really frustrating thing was that the reason why I couldn't use a lot of these papers is because different papers on the same topic use different methods, different analyses, different everything. So many things were different that how can you compare apples to oranges? So because of that, I'm actually working with people at CUNY School of Public Health to try to develop guidelines for what is a good reporting of your microbiome study, and how can you make it so that a paper from China can be compared to a paper from the United States. And something else that was weird and frustrating was that some bacteria reported up and down for the same condition. So what does that mean? Does it mean we should ignore those things, or does it mean, is it a technique thing? What does that mean? So it's something for further exploration. And so because I had such low numbers, I couldn't really run statistical analyses for real. I did run some preliminary Fisher exact tests just to see if these overlapping bacteria were identifying colorectal cancer and diet as independent. And they actually were not, but I would not really take much stock in that because the N's were so low. So I need to continue working on that. So for future directions, I have a lot more work to do. This is going to turn into my capstone project. So I have a lot more articles to curate, and hopefully I will continue to find overlapping changes in the microbiome between diet and lifestyle. One other thing that was just interesting that I came across is that, how do you define diet? So there were a lot of problems in defining diet in the literature. Some studies that were really interesting just focused on, for example, mushroom consumption, which is really important actually, but how do you just compare a study looking at the changes in the stool after eating mushrooms for 6 weeks to, say, a standard American diet? It's very difficult, so we kind of have to work on defining what diet means. So I talked about working with the CUNY faculty to set out guidelines for microbiome research. So what's important to be in microbiome research reports to help researchers compare across groups. I think it would really, it's really important. A lot of studies have been done in animal models, but not in humans. The timeline, so I'm trying to say that changes in the gut are associated with colorectal cancer, but we don't know which came first. So it would be really important to do a prospective cohort study looking at cancer-free patients and following them over time while taking the stool samples over time to see if changes in the gut microbiome precede the development of cancer. But you have potential here for interventional study to supplement at-risk individuals with probiotics. People are already doing that actually. They take cancer patients, and after the tumors are removed, they actually give them supplementation with probiotics to see if they won't redevelop cancer. So it's already happening. So learning experience, as a lot of people have already said, you need to estimate double, and that's really an underestimation of the time that you think you need to conduct research, because it's really a lot more than you think. This area of research needs a lot more attention. There's so much stuff out there, and there's a lot more for people to work on. What's interesting that came out of this is that there's a lot more work in the exact thing that I did. So for future CSP students, if they're interested in this topic, there are so many articles out there to be potentially curated. But also, because of my work with CSP and cancer, I was asked to start working on another project on the microbiome, looking at HPV status and the oral microbiome. So as some other people mentioned, HPV, there's high-risk HPV strains that lead to cancer. And so it was because of my involvement in CSP that I've been asked to do this work, which is very exciting because we actually have the raw data so that I can actually do that work. Another thing I learned is that consistency and guidelines in research are really necessary to help people compare apples to oranges. And I'm so fascinated by these results. I'm absolutely continuing this work, and I'm certainly making sure to include more fermented foods in my diets or probiotics because I see how important it is, even if I don't have the strongest evidence yet. So I just wanted to say thank you so much to Dr. Solomon for allowing me to participate in this. As I said, I'm a non-traditional student, but I really have benefited from this experience. Dr. Waldron, my mentor at CUNY SPH, and his postdoc, Dr. Geisler, were both extremely helpful in getting me started in doing this research. And of course, the CSP staff, Syed, helping with all the, productions. Are there any questions?